Okay, so I was recently asked the question of why does a car on a semicircular hill have imbalanced forces? Why is the force normal up from the hill not equal to the force of gravity down on the car? Well, first of all, let's just draw a free body diagram for the car showing the force of gravity and the force normal. Now, we know that this car is going on a semicircular hill, so let's just complete the circle over here. This doesn't actually exist, but I'm just completing it for reference. Now, this circle has some sort of radius, and the net force on any circle is directed inward. But why is that? Well, if a car, let's just say we have a car, and the car has a force on it exerted to the right, then the car will have an acceleration to the right, or I'm sorry, if it has imbalanced forces to the right, then the car will accelerate to the right. But if the car has a force down and to the right, then the car will instead accelerate like this. But instead, what if we take it so that the other force is constantly changing? So as the car is over here, the net force is directed inward. When the car is here, the net force is still directed inward, and that when the car is on top, the net force is still directed inward because it has to stay moving on this circular pattern. If at any point the net force is directed somewhere outward, the car will just move in that direction. Let's take, for example, a car, a semicircular hill, and let's just say, for example, that the force normal was greater than the force of gravity. Well, that means that the net force is up. But then that would mean that acceleration is up, which would mean that we have a flying car. Now, obviously, this car is not flying, it's going around the circle. And since we haven't invented a car yet that can just go up, I'm going to assume that the car here is on wheels and that it's staying in contact with the ground. Therefore, the force of gravity has to be greater than the force normal. Now, you may be asking, why can't the force of gravity be equal to the force normal? Well, then again, realize that if the force of gravity was equal to the force normal, these are both forces on the y direction. So if these two are equal to each other, then the net force in the y direction is equal to 0, meaning that the acceleration on the y direction is equal to 0, meaning that the car, instead of going on a circular path, will just go straight to the right, because there is something propelling it this way, some sort of the force of friction from the tires onto the ground is propelling it to the right. But if there was no net force down, then the car would just continue to the right and it would just float on air as it went. Or it would fall slowly in contact with the ground because the force of gravity is not equal to the force normal, and it's in fact greater than the force normal.